All right, this is Oracle's standard safe harbor statement. Basically saying I'm going to be talking a little bit about some Oracle products and some non-Oracle products, and basically just don't take anything I say as any type of future prediction on what Oracle's going to do. I probably don't know that kind of stuff anyway, so don't make any purchasing decisions off of anything that I talk about. Howdy, I'm Blaine Carter. I'm Oracle's developer advocate for open source. There's all my contact information on the screen. My job at Oracle is I work at the intersection between open source and the Oracle database. So what that means is, on the one hand, I look for open source applications that are going to be useful for database developers to help them do their job a little bit better. I learn a little bit about these applications, enough to help other people get started with them. So I do a lot of different things here and there. And then on the other hand, if there's an open source project out there that might need a little bit of database help, I can assist with anything from intro to database development all the way up to the more advanced features of the Oracle database. And while I actually do know everything, I can't remember it all at once. So if you have a question, there's all my contact information. Hit me up on any of those channels and I will do my best to help you find an answer. But today I'm here to talk about modern database development processes. So when I say that, what I'm really talking about is when you're developing software, you should be working from some sort of a specification, whether that's in a waterfall method, that might be a big requirements document, or if you're doing something agile, that might be like Kanban cards or storyboards. Whatever it is, make sure that everybody agrees on what you're doing and write it down. You should be using some sort of version control for all aspects of your application. Basically, if you want to keep it, put it in version control. If you don't care, don't. And that includes your PL/SQL files. I highly recommend that you write your PL/SQL code, save it to files, compile those files to the database. I know some people who still like to code directly into the database, and it works, but in the long run you're going to run into a problem sooner or later, and you're going to wish you had been saving those off to files and checking those into version control. You should be doing good tests, so whether that means you have a good testing team who has a set list of tests that they do, or whether you're using some sort of automated testing software, just make sure that you have good test coverage and you run your tests often. You should be tracking your bugs and enhancement requests in some sort of a database. I know some people still use spreadsheets to track their bugs, but the larger your team gets, pretty much anything above one, the more difficult that's going to be for even the most basic example is those spreadsheets are going to get different copies and out of sync, and then that will lead to disagreements. All right, build tools. If possible, you should be using some sort of a build tool. If you're old school, this might be something like Make or Ant. Some of the newer tools are like Maven and Gradle, but basically what these tools do is they collect up all of the different pieces of your application and package them for you and get them ready to deploy. And of course, some of these tools come with some different levels of automation to maybe run your tests or run other applications, but you should try and automate as much of this process as possible. And all of this kind of ties into the concept of DevOps. When I say DevOps, a lot of times the first thought to people's mind is, hey, new shiny tools. And so there are a lot of tools to do those processes I talked about, but it kind of just ties into DevOps. When you think of DevOps, you should really think more about the culture. And so what that means is it's different. It's how you interact with other people on your teams. And by teams, of course, there's developers and operations, which is what DevOps comes from. But there's the QA testing team, there's documentation, there's database, and security. And especially those last two, a lot of times the database and security aspects get kind of left out of the planning and the rest of the process. They'll put all the stuff together and say, here's what we want, and throw it over the wall and hope something good comes back. But what you really should do is at every level of the process, you should have representation from each one of these teams involved, whether that's from the initial concept all the way up to the final, the customer has it and you're troubleshooting bugs. But of course, if you look online, you're going to find all kinds of sites out there that can really give you a better understanding of how DevOps works. So of course, I like to do the fun stuff, so I'm going to talk about some of the shiny tools. So for example, one of the tools I'm going to use is called DinoDate. DinoDate is a little tongue-in-cheek application that we put together that its intention is to demonstrate some of the different Oracle features and how to use them with different languages. So for example, there's a middle tier written in Node.js, and there's also a middle tier written in Python. They basically do the same thing, but if you're a Python programmer and you want to learn Node, you can compare the code or vice versa. So for example, if we go into the search screen here, and I'm a dinosaur, I'm looking for a date, I want to go out and do, have some dinner, so I'm going to look for eat. So if I do my search, these are the dinosaurs that are interested in going out to eat. And also, so this is a text and spatial query, so it not only used Oracle text for eat, but it also limited it to the dinosaurs within 1,000 kilometers. Now I can change this to either just straight text or even a like statement. So with a like statement, now I'm searching for percent eat percent. And if I make that lowercase, I should get a few more dinosaurs. There we go. And so what this does here is if you click on these little gears, it'll actually show you the code that was used to run those queries. So this is the Node version, so this is the Node code, and you can switch back and forth and see how that works. But anyway, I'm going to be using DinoDate as the example of how to run through the process that I mentioned, and I'm not going to get too much deeper into DinoDate. Just know this is the application that I'm planning to use. And if you go here on GitHub, on the Oracle account on GitHub/DinoDate, you can download that, and all of the examples that I'm going to go through later on should be there. If you find anything missing, let me know and I will get that updated. Now, in the end of the process that I'm about to show you, the final deploy would be normally going to Oracle Application Container Cloud Service, or ACCS for short. I'm in the process of moving DinoDate from ACCS into OKE, which is Oracle's Kubernetes engine, mostly because Kubernetes is new and shiny and fun, and like I said, I like to learn new things. So as a process, I'm learning Docker, Kubernetes, all of that stuff. And so the next time you see me do this talk, it'll probably replace the ACCS bit with OKE bit. All right, so after all of that, you're probably looking at this and saying, well, yeah, but database development is different. We have different issues, certain things that other languages find simple can be a little more difficult. For example, version control, and not specifically the code, but more along the lines of your schema objects. So your tables, your views, whatnot. You should be version controlling your database objects the same way you would version your code. And so you could do what I've done in the past. So in the past, I've set it up to where I have two different sets of scripts. And in the first set of scripts, I have all of my create a new database for the application at, say, version 4 or 5 or whatever the version is. But if you're a new customer and you're loading up version 5, you run these scripts and you get the brand new clean database. And then I'll have a second set of scripts that are all of the changes that get me from version 4 to version 5. Another one, version 5 to 6, and so forth for each version. And so I maintain a lot of different scripts, and in each one I have master run scripts that will run these other scripts in the order that they need to run in. And so this can work, and I know a lot of people still do it, something similar to this nowadays. But you run into issues. So for example, how do I tell when the scripts were run? Did they all run? Who ran them? were there any errors, any of that type of stuff. And that's all, you can do all of that with scripts, but usually to answer those questions, you write more scripts. And so you wind up with more scripts. Do you test the scripts that track the information on your scripts? How easy is it to get that data back out? It's doable, but it can start to snowball and get really difficult really fast. Or there's an easier way. I'm going to talk to you a little bit about a product called Liquibase. Liquibase was put as an open source project. It's not an Oracle tool, but it works really well with Oracle. It's maintained by a company called Datical, and it's a very active project. So if you have questions or bugs or whatnot, just go find their GitHub account or look on the Liquibase site, and they're very friendly people. They will help you get through your issues. This is what's called a schema migration tool, and there are quite a few of these out there. Another open source one that I haven't quite got into yet, it's on my list, it's called FlyWayDB. It's funny, that list keeps getting bigger and bigger, and I keep learning new things, but I never quite make that list smaller. But anyway, it's called FlyWayDB. It's similar to Liquibase. It works mostly off of scripts. Like I said, I haven't used it, so I'm not exactly sure of the differences, but I've heard good things about it. There are other ones out there. If you're a Python programmer, I believe you pronounce it Django, has a schema migration tool built in. If you're a Ruby programmer, then there's Ruby active record migration. There's tools out there for pretty much all kinds of languages. One thing I really like about Liquibase is it's a Java application, which means I can run it anywhere, and it's not tied to Java. It's not tied to any specific language. It's just its own tool, which makes it nice for someone like me. I like to do a little bit of everything, and so I don't have to learn a new schema migration tool every time I change a programming code. But the short version is you can think of this as version control for your database schema objects. The way that it works is you create these things called change sets. And think of a change set as just a different way of saying, hey, here's a different kind of script. But you're only tracking the changes. You're not going to write a set of, here's a brand new database. Your first change set would probably be create this table. Your next one might be, if you're working on that same table, you might write another one that says here, add a different column or drop a column or add a constraint. Each change that you make would be a new change set. And when Liquibase runs these, it keeps track of the ones that it's already ran, and it picks up where it left off, and it moves forward and runs the remaining change sets. And the way that it does that is it takes the change sets, which can be written in XML or JSON or YAML or even Groovy. I think there's a couple others in there. You can write them in SQL with the commented notation in there. But what it'll do is it will take the change sets that you write and convert those into SQL. And if you're working in a shop where maybe your DBA does not want some random tool running SQL against their database, you could generate the SQL instead and hand them a script, and it will include all of those change tracking things that I talked about before, who ran it, when it was run, all that type of stuff. So that's kind of a handy feature. So the way that it works is it tracks the changes. So every time I run a Liquibase update, it tracks who ran it, what was run, when it was ran, all of those different things. And those are tracked in tables in the Oracle database. Well, in whichever database you're working. It works with multiple databases, but of course we like Oracle. Most of the changes that you make, so if you run a change set that creates a brand new table and I didn't mean to run that yet. You can just type in Liquibase rollback 1 and it will roll back the last change. It'll figure it out for most things. So things like adding a table, adding a column, maybe adding a view, different things like that. Liquibase will be able to automatically roll back changes. Some changes, like if you write a change that say changes data, for example. So if you add some columns or drop some columns or update, it's not going to be able to automatically roll those changes back because Liquibase is not a point in time backup utility. It's just running the change sets. So if you have something like that, you'll have to add in your own rollback statement. And I'll show you a bad example of that here in a second, but it's fairly easy to do. You can run it with certain conditions built into your change set. So for example, if you're running a test and you want to make all your changes into the test database, tests usually require some data, and so you might have a change set that just loads data. It's just test data. You don't want it run in production, so Liquibase gives you the ability to add a test condition to that change set, and then it only gets run when you're running your tests. Kind of a useful feature. And then when things go wrong, notice I didn't say if, but when things go wrong, you can run a diff between your current schema and the schema that Blaine's been working in and messed up. And when I run that diff, it'll tell me the differences, and if I want to just forget everything I did and make my database match the known good database, it'll generate a change set that gets me back into sync with the regular database. One of my favorite features of Liquibase is it auto-generates documentation for my database. I am terrible about writing documentation for my programming applications. I don't like to comment. I don't like to write docs. I actually like to. I find things that are more fun to do, and I get a little easily distracted. But the documentation looks like this. It's written using the Java doc style format, and so this was actually generated with the DinoDate Liquibase changes that you can see if you go to the GitHub account. But you can go in here and you can see that it has listings of these are the current tables in the system, and you can drill down into the different columns. You can look and see who has written change sets. If you want to see all the ones that I wrote, you click on that and you can see a list of the change sets I wrote. Now these have all been run. If they had not been run, I could click here to see the pending SQL and just copy right out of here, run it in the database, and it would make the changes. And like I said, they've all been run, so there's no pending changes here. But here you can see these were the most recent changes that I ran. So it's kind of a nice little documentation tool, and I think it looks pretty cool. And you just run a command, and boom, it's generated. So let's take a look at a change set. So in this change set, if you go out and look for Liquibase examples, you're probably going to find most of the examples are using XML. Now, I think XML is a little too pointy, and you're going to cut your fingers on that stuff, so I like to use JSON. If you're not familiar with JSON and you just kind of read through, on this side of the colon, this is called a key. On the other side of the colon, that's the value, key value. And then this means it's an array, the little square bracket, and then the little squirrely brackets, those mean it's an object. So this would mean it's an array. Here's the first object in the array. Simple enough. And then here, this is a very useful feature that comes with Liquibase, is I'm going to run some preconditions. So before this change set runs, it's going to go out and double check, am I running this as the user DD for DinoDate? If I'm not, then it's going to not run. It's going to throw up an error saying you're on the wrong user. Fix that, because I don't know about you, but I am tired of running my scripts in sys or system and then having to go back in and clean that up. So this makes sure that everything runs in the correct schema. I pretty much include this piece on all of my change sets just in case. Alright, so down here we have an actual change set. Here's some information to keep track of the ID of this particular change, and this is who generated or who created the change. Now notice it's got bcarder generated. That's because I used the reverse engineer feature of Liquibase to pull these change sets out of an existing database. And so it tagged my name as the one who ran it, and then it was generated. So now my changes are, I'm going to create a table. It's named DD members T. It has an array of columns. First column's name is member ID. It's a number, auto increment true. So in Oracle, that's going to be an identity column. And here I'm setting up some constraints to make it the primary key. If you're using MySQL, I think they call it an increment column. It's been a long time since I did MySQL, but with this particular change set, it will spit out the SQL in whichever database language that you tell it to use. So that's kind of a nice feature. Down here we have our dinosaur ID, that's a number. Location ID, that's a number. Here's the name, it's a string. This one's not null. The email is not null and it's unique. Here we have a CLOB. This one we're setting the default value to P, subscription status pending. Down here we're using the default value computed. So created by, what I'm doing here is I'm checking to see, I'm using the coalesce function, and this will say if I'm running Apex, then use the app user. If I'm not, then just use the regular database user. So just a little piece of code to depend on which user that I'm checking or which I'm running with. Not null, same thing there. Here's a timestamp. There's a timestamp. Down here we're adding a foreign key constraint and another one there. And so that's a fairly basic change set for creating a table. Now, I mentioned that these change sets are all run using a changelog master, similar to the way the scripts run. Here I'm just saying include this file, and this file will create a table, and so forth. Notice here I have a directory called run once. If we get down here a little ways, you'll see I have another directory called run on change. So a couple different options with Liquibase. I have a change set that will create a table. I only ever want to run that once, ever. After that, I'll have a change set that might add a column or drop a column or whatever as it goes on. But each of those, I only want it to ever happen once. If I go to stand up a brand new database, it will start at the beginning and run all my changes in order. However, stuff like PL SQL, views, triggers, functions, procedures, I keep that, like my PL SQL code, I keep that in Git. And so if I make a change to my PL SQL code, I check it into Git, and Liquibase will go out and look to see if that code has changed. If the code has changed, it will rerun that script, and that may be usually that's a create or replace type statement. And so that's how I track that, and this is what one of those would look like. So same precondition here, but down here I'm saying run on change equals true, and then create procedures, just a generic term for run this script. Procedure, function, package, they're all considered a procedure for as far as Liquibase goes. This is saying I'm using an Oracle database. There's my encoding. Now this particular file, I'm telling it to run relative to this changelog file. So that's why I have the .. to go up a couple directories and then down into where I store my actual package code. And then what will happen is if I change this, commit it to Git, that kicks off the build. We'll talk about that in a second. And it will rerun this code. Next time I run Liquibase, if I haven't changed this package, it'll just skip it. It won't rerun it next time. Now here's that bad rollback example I was talking about before. If you're doing something like PL SQL, you do need to include some sort of a rollback statement, or if you're rolling back a sequence of changes, it will hit this one and stop and say, I can't roll back PL SQL. I don't know what you did. I don't keep track of that. So normally I would have a rollback and then I would just say don't do anything. But I wanted a little code in there, so I wrote a bad example. Here I put a little SQL call that says drop the package. If I'm actually going to change my PL SQL and then roll it back, I don't want it to drop the package. I would change it in Git and then it would just rerun. So don't follow the code in this example for your rollbacks for PL SQL. Just tell it to do nothing. And you can look up those examples in their documentation. They've got some really good documentation. But anyway, that's a very basic level, entry level intro to Liquibase. But schema version control aside, database development is still a little bit different, specifically testing, and more specifically unit testing. So when we talk about unit testing, there are a few things that we need to be able to do in order to run a decent unit test. At the very basic level, we need some sort of ability to set up, meaning before I run my tests, I need to set up the environment so that it looks the way that I want it to be for my tests. That could be some setup before any test runs. That could be set up before each test runs. We need the ability to be able to execute our code, obviously, so we can validate that whatever happened was supposed to happen. And then when everything's done, we need to be able to clean up after ourselves to put everything back where it was. Your mom doesn't work here. Maybe she does, but she didn't work with me, so I have to clean up after myself. And so this is the same as setup. This might be after each individual test, or this might be a final cleanup at the end, any combination of the above. All right, so what about PL SQL? Other languages out there like Java and Node and Python, they have a lot of choices for testing tools. There are a few choices for testing PL SQL. One of my favorites, probably my favorite, is UT PL SQL. This was originally written by Stephen Feuerstein long ago, and as he moved on to other projects, it was picked up by Jacques Gabal. I probably said his name wrong. I apologize, but it is being currently maintained, and it's a very active project. So if you happen to be a PL SQL programmer but you still want to get into open source, this would be a very good project for you to get involved with, to learn how the open source process works, pull requests and all of that. The UT PL SQL group is very responsive. They have a Slack channel, and they respond on GitHub. Great group of people. So the way that it works is, yeah, that's where I wanted to be. The way that it works is for each unit, and so a unit would be, say, a function inside of a package. You're not going to consider the package as a unit, but just the function inside of the package. And so the way that UTPL SQL works is you'll write a package of tests just for that unit, for that one function. And in this case, my function is called generate members. So if you go back to DinoDate, when I'm running those different queries, like when I ran it for text and spatial versus just using a like, they both reacted pretty quickly. That's because DinoDate by default only has 41 members, dinosaurs preloaded into the system. And so running a speed test between those two is probably not going to be real impressive with just 41 members. So generate members will just randomly generate a whole bunch of members that you can run tests against. And this particular function is stored in the DD admin package in the DD schema. So the suite path here allows us to be able to run these at different levels, and I'll show you how that looks here in a second. But the entire set of tests belong to the DinoDate test suite. So the way UTPL SQL works is you'll notice the comments and then the word with the % sign. This is just commented out annotations, so you can compile your code and the database will ignore it, but when you run UTPL SQL, it will look for these keywords and do certain things based on what you put here. Another thing to note here is this particular function has a commit in it, and if I don't say rollback manual, then UTPL SQL is going to see that commit before I run it and go, you got a commit in there, I'm not touching this. And so this is me saying, I know, I put it there, I take responsibility. And so if you don't have a commit, you don't need this. All right, going back to the setup, you'll see here we're saying before we run any tests, run this procedure. When they're all done, run this procedure. And I don't have a before each because my after each is going to clean up the environment after the test to get it back the way it was before I ran the test. So I do have an after each, I just don't have a before each. And then here we have our individual tests. So the first test is this should generate 10 members. And there's the test name. This test should generate 19. This test should generate 0. So let's look at some of the farther down code. All right, here we have a little helper procedure that I put in there. I have a safety valve in there that I typically keep set to 10,000. So if you log onto the system and you say generate 1 billion records, it's going to stop you at 10,000 going, that's probably enough for what you need to do. But you can change that if you want to install this in your own system and make 1 billion, set it to 1 billion. but I wrote this little procedure just to update that value, because when I run my tests, what I'm testing to see is I tell it to generate a certain number of members, and it will return here's how many I generated. And so I want to make sure that I get the right number of members, and having 10,000 members in the system versus having 60 members in the system, my tests are not going to be any different. So that's why I set this that way. As you can see in the before all procedure, I'm setting the max members to 60. And I also have a helper function or procedure in here called delete added members, which will delete everything above those initial 41 default members. So I have the exact same environment every time I run a test. Alright, so here when everything's done, then I set it back to 10,000 members, and I clean up the added members. Alright, so there's the delete function. Alright, first test, generate 10. So when I call the generate members function and pass in 10, I expect it to return the number 10. So UT for UTPL SQL, expect that when I run this, I expect that to equal 10. Simple enough. Down here, remember I set the limit to 60 and I only have 41, so now I expect that if I tell it to generate 10,000 members, that it's going to only return that it generated 19, because it'll hit that limit and stop. And then here I want to test being at or above the limit already, so here I set the limit to below what I already have, so I set it to 10, and then same thing, I tell it to generate 10,000, and I expect that to kick back a 0. And then once that's done, I set it back to 60. So this is an example of a little pre-setup for this particular procedure, or for this particular test, and then its own cleanup after this test runs. So basically the reason I do it this way is I can run these tests in any order, and this test is not going to mess up this test up here. Alright, so that's a very simple example of a suite of tests to test the generate members function. Alright, the way we run UTPL SQL is we set our server output on, we set our feedback off, and then we execute UT run. And that's going to go out and run all of the tests, and then it'll print out this nice, pretty formatted report where, remember the path that I had set up, it's going to show that for the schema, for the package, for the function, in this particular suite, I ran these 3 tests, that's the time it took, and here's the results of those tests. Now I could run UTPL SQL just for the admin package. Let's say I have a whole bunch of tests, which I should have a whole bunch of tests in my system. I could tell it run all the tests for just this package, or just run the tests for this function. So that suite path is a nice way to control what level you're running your tests at. Alright, so that's a very high level overview of UTPL SQL. Great program. I encourage everyone to go out and give it a try, get involved with the group there that is maintaining that project. So what we have now is we can take the schema migration that we're doing with Liquibase and our unit testing that we're doing with UTPL SQL, and we can work on making a CI/CD pipeline. So if you're not familiar with the term CI/CD, that actually stands for 3 different things. So CI stands for continuous integration, and what that means is if I'm using some sort of a version control system, let's say Git, for example, or Subversion, whichever it is, and I have the ability to do branching and merging, okay? Continuous integration means that as a developer, I check out my code, I make a new branch, I make my changes on the branch, and then I check that branch back into the shared repository. Continuous integration will notice that I made that check-in. It will go out and do whatever it needs to do, whether it's run some tests, whether it's package things up, but it will do the things that it needs to do to merge that back into main. So continuous integration means at all times the code is merged back into main. Alright, so that's continuous integration. That's the first level. Okay, the next level is continuous development. It does the continuous integration part, and then it goes one step further. it will run whatever tests it needs to do and package it up however it needs to be done, and it will create a deployable object. So depending on what language you're using, for PL SQL or for database programming, this might be a package of scripts with a master run script in a zip file, for example, that I could hand off to a customer, or I could give to customer support, wherever it needs to be. But that same process, the developer checks code in, it does everything it needs to do, and it makes a deployable product, artifact. Okay, continuous deployment is the final step on that. It takes that deployable object, artifact, and deploys it to production. So that's the one that's kind of scary. If you're shooting for that, start at the top and work your way down. Make sure you have excellent test coverage. The better testing you have, the more happy you will be with this process. But at any given time, a developer can go out and knock out a code change, and it will run all of the tests, it will package everything up, and it will deploy to production. So every little change is always live. So it's kind of a cool concept. It's a little difficult to get there, but it's worth it in the long run. All right, and so these are all controlled through what's called a CI/CD pipeline. Now, my pipeline for DinoDate is very, very simple. It's a straightforward one. It looks like this. So the first step of my pipeline is I check all of the code out of Git, and if there's things that I need to build. So let's say I'm doing the Node version. I take all the Node pieces, I run npm install. I'm using Oracle Jet. I'm actually using an old version of Oracle Jet. I really need to update that. So I'm still doing a Bower install. The current version, I would do an OJet build. But whatever I need to do, I build all those little bits and pieces, and I get them ready so that I can test. Okay, and with that I'm using Git, and like I said, I'm on the Node version there, and so I do that step first, and at that point I keep all of those artifacts that I checked out, and I store them in the first step, and I'll show you what that means here in a second. But none of the next few steps, nothing ever goes back to version control. I don't check out again, and that's to prevent, if I've got multiple developers working and I make a change and it kicks off the pipeline and my tests ran and then somebody else checks in code, it doesn't pull that untested code out and continue on. And now there are ways that you can ensure that it doesn't do that again and it just checks out the same piece of code over and over again. But this way I feel more comfortable with this method because it kind of guarantees that here's the code I've got, and I keep that same code all the way through the process. It's just my personal preference. I prefer to do it that way. All right, so once that first step's done, then I run my Liquibase changes, and I track my product changes and my UTPL SQL changes both in Liquibase, and I check the Liquibase changes into Git as well. So this will deploy my product changes and my tests. And of course the next step is I run UTPL SQL to test all of my PL SQL. If all of that works and the tests pass, then I go back to Liquibase and I generate the documentation. So there's really no reason to generate the docs if the tests fail. So it just kind of saves one command there. It doesn't hurt me any, it doesn't cost me any time that way. And then once that's done, I go back and I take the Node artifacts and the Oracle Jet artifacts and the Liquibase artifacts for the documentation. I repackage all of those up into this nice, pretty little zip file that, whoops, hit the wrong button there. Oh, good. I package that up into this nice little zip file, which can be deployed directly into ACCS. And then it's just up and running. So at any given time, I make a change, I hit commit. All of this stuff happens and my changes are live. So for that, I'm using a product called Oracle Developer Cloud Service, or DevCS for short. This is a suite of tools. Most of them are open source that Oracle's kind of put together and done the pre-configuration, the integration ahead of time for you. So for example, if I remember all the logos, obviously Git's easy. Apache Ant, Apache Maven, that's both the Maven build tool and the Maven artifact repository. Gradle, Grunt, Gulp, Node, Bower, PHP, Python, JUnit, I believe that's called Findbug, and SE Linux, or not SE Linux, Selenium is the last one, and quite a few more other tools. These were just the logos that I got to fit on the screen. All right, so let's actually go take a look at DevCS. Now, DevCS is, if you have an Oracle Cloud account, then you should have access to Developer Cloud Service, or DevCS. And this is what it will look like when you come in there. So you create a project, and when you open your project, this is the home page, gives you a bunch of reports on the last few things that have happened. Now, it includes a Git repository, which I store all the DinoDate code on GitHub so that it's accessible for everyone. It's pretty much where everybody puts their open source projects. I put that out there. I could put it in here. I could keep a copy in both places. I probably should keep a copy here just to be safe. But anyway, right now it's not stored locally here, but I could. And you can have multiple Git repositories in DevCS, so maybe there's some things you want to keep private. You can put those in here. Merge requests is a section on code review, so a really good, highly recommended process is when you've made a change, make sure it goes through a code review before it kicks off the pipeline. So make sure somebody gets eyes on your code. This is the Maven artifact repository. So similar to how I was talking about that I like to just check out of Git one time for my pipeline, I also prefer to store my dependencies in somewhere local. So here I have the version of Oracle Jet that I'm on. Like I said, really old version. I will be updating that soon. The version of UTPL SQL and Liquibase that I'm using for my project. I don't know if you remember a year or two ago, there was this big blow up in the node world. There was this little tiny module called LPAD, because apparently LPAD is hard in Node. I'm not sure why they needed that, but all it did was it did an LPAD function, stuck some spaces on the left hand side, and there were a lot of really big projects using LPAD, and the person who wrote LPAD took it out of the repository, and so all of these projects that had a dependency on LPAD, they all broke. And so storing things local is one way to avoid that situation in the future. If one of your dependencies updates, you go get a copy and you put it in the local repository. So that's what I like to use the Maven repository for. Here's a tool to link out to some external Docker registries. Here's a place for you to put your releases. So maybe you give customers access to this page, they can come and download your latest release. If not, maybe your customer support people come in here and get them. I'll come back to builds and deployments, environments. Here's you can set up different environment variables. I'm not sure the best way to explain environments other than to click on the learn environments, but you can set up different product stage, read that and it will explain it way better than I can. Let's see, there we go. Bug tracking here, built-in bug tracking system to track your bugs and enhancements, and some agile boards. So this is both Scrum and Kanban. If you want to do Scrum and you want to do Kanban, you can have multiple of each type of board in here to track your agile process. There's a built-in wiki. We all have those little code snippets that we keep in. I keep mine in a utility directory that are really handy, and I use them on lots of different projects. You could put those in here and share them with the rest of the team, mark them as favorites. Nice little way to share your snippets. Back to builds. All right, so all of those extra tools, if you want to see more in-depth detail on each of those other ones, look for some presentations and some blogs and videos by Shai Smeltzer. I never can say Shai's last name. It's S-H-A-Y. Look him up. He's got some great material on this stuff. But I'm going to jump into the build. So this is what I want to focus on. So these are my individual steps in that build chain that I was talking about, in that pipeline. And so my pipeline looks like this. I have a slightly forked pipeline here. Normally when I check into Git, this particular step, this source change step, will be monitoring my Git, and when that changes, it will kick off at this stage, run the update, run the tests, run the docs, and package everything up for deployment to ACCS. If I'm installing to a brand new database, I have a couple extra steps here. This one will actually create all of the schemas that I need for my application, and then it will install UTPL SQL, and then it will kick off the rest of this. And so this one doesn't actually run Liquibase, it just gets all the extra schemas that I need for my application. This will create my the update DB step here will create the application itself, or the database schema itself. Alright, so I'm going to kick off this pipeline and see if I can explain stuff before it gets done. So I probably should have started that up before. Let me explain what the executor is. So back in the organization level, you will define these virtual machine templates. And so I've defined this one, and in here, you can pick all of the software that you need for your application. So there's a whole bunch of different stuff in here you can use. And so you'll set up a template, and then you'll set up these build virtual machines. And I guess I might as well kick that one off while I'm in here. What I've done here is I've set up 2 different build virtual machines that will start running, and these are Oracle Compute instances. So when you're probably wondering, how much does DevCS cost? DevCS only charges you for the times that these 2 instances are running, and you can tell it how many minutes you want them to stay on. So you might want to tell it an hour, 2 hours. I set mine up to stay on for 1440, what's that, a full day, just because I'm not paying the bills. But basically, however long they're on, you're just getting charged for those compute instances, and they're one of the smaller compute instances, so it's not going to cost you a whole lot, and if you're not running a lot of builds, it's going to cost you next to nothing. So let's jump back over here, and so that's how we set that up, and so that's what it's talking about when it's waiting for the executor to start. And sometimes it takes a few minutes for that executor to first get booted up, because it's not only booting up the compute instance, but it's installing all of that software that I asked for, because it's creating a brand new, fresh, clean instance. So we might not get through that by the time I get through the end of the pipeline. But let's take a look at some of the pipeline steps. So here is the source change. Let's go look into there. And you can see the first tab here, I'm telling it here's the GitHub repository, and so I want it to check out of Git. I'm not using any configuration parameters. This would be if you need, like, to say ask the user for a password or different information here. You'll put that in there. Before build, I'm not doing anything there. I'll come back to that step in a second. And then the actual step I'm doing, this is basically just a shell script. So this first curl statement here is connecting back to the Maven artifact repository and pulling the objects that I'm going to need out of the repository. Now I could link in directly. There are ways to do this a little cleaner if you don't like curl. I don't know, the curl statement for me was easier to write than the other, so I slammed that in there because then I have it all in a nice shiny shell script. And then here I change into the directory. This is where it checked the stuff out of GitHub, and I zip up some of the pieces that came out of Git that I'm going to need for other parts of my application. I go into Node, I do the npm install, I go into the Jet directory and do a Bower install. Once again, I'm many versions behind on Jet. I need to update that. And then I go in here and I make 2 additional artifacts, one for Node with all the npm stuff done, and one for Jet with all the Bower stuff done. Once that's done, we archive all of the zip files that I created, and we hold on to those for the future steps. And so you can come in here and look at the Artifacts tab and see all of these I can't select that. See all of the different zip files. And if I wanted to pull one of these down just to see what it was, I can download those from here as well. Alright, so that's the first step there. The second step would be running Liquibase. And so I'm going to jump into here. And first, notice there's no Git. Like I said, I only go to Git one time. And then from then on, in my before build step, I say copy the artifacts. Oops, I just moved that. I don't want to move that. I guess it doesn't really matter. I say copy the artifacts from that first job, the source change job, and you can see a list of all of the other jobs. And then I say when only the last successful build, and I want the Liquibase zip file, and then down here I want the core database zip file. That's all of my scripts in case I want to do one or the other. And then up here, this is a really nice feature I like in DevCS. This is allowing me to set up an SSH tunnel to my database, which is located, there's my IP address. I should probably change that. I think that's an old one. This is the IP address to get you to my database, and this will use my key that I entered up here and connect into my database through create an SSH tunnel. The reason this is kind of cool is when we get to the steps, in here you'll notice that I'm running Liquibase twice. Here I'm loading the driver. Here's where you find the driver. Here's the connection string to get to my database. I can just say localhost here and connect to my database. When I destroy that database and make a new one, which I do frequently, I don't have to change the IP address here and in several other places. I can just go back into that SSH tunnel, change it there, and everything runs. So it keeps it nice and tidy, and it's also accessing through the SSH, so I don't have to open port 1521. So that's another bonus. Alright, so there is the command to run Liquibase. I'm telling it to just run an update, and here is that changelog master. Alright, back out to here. Oh, looks like it kicked off and it's already passed me. It's up to the docs generation step, so you can see right there's the current one that's running. We'll jump into the UTPL SQL step. Everything else is pretty similar to the Liquibase step. Here I'm using Oracle SQL CL, and I'm connecting into the database. Once again, it's using a tunnel, so it's localhost, and then I'm just running this little bit of SQL. Now notice when I execute the UT run this time, I'm passing in an UT XUnit reporter. What this does is this will format that pretty report that was in the step that we saw before into something that's an XML JUnit style document, which I'm spooling out to a file I called results. You can call it whatever you want. That's just what I called it. After the build, I'm going to archive that file in case I want to pull it down and look at it, because I like reading XML. Not really, but I could. And then down here, I'm going to tell it use the JUnit publisher to publish those results to the pipeline step. So if we go back out to here, you can see that we have this test step, and in here we can see a report of all of the different tests that ran. We can drill down into each test and see that it passed. It took 1 second to run, that type of stuff. So you can get some really useful information out of there. And if those tests fail, then my pipeline ends right there. Okay. After that, generating the docs. It's pretty much the exact same as the Liquibase step, other than I call dbdoc and I tell it to put it in this directory. And then finally, the node ACCS step just takes the node objects from the other builds and then repackages them into a single zip file for deployment. And that's pretty much the build pipeline, with the last step being the deployment. I haven't set the deployment up on here because, like I said, I'm switching over to OKE. So currently I'm not at continuous deployment, I'm at continuous development. So I have my packaged build application ready to go. To get to the last step, I would go in here, I would give it a name, and then I would tell it that I wanted to connect to ACCS. Now, if I'm doing Java, I can also connect to Java Cloud Service or Java Cloud Service SaaS extension. And here I would say automatic and tell it to watch that particular build step and grab that artifact. And once I have the connection set, I add in a little bit of the manifest stuff once I hit the next button, and this would automatically deploy, which solves the final step of the pipeline. Alright, so that is a really high level overview of Developer Cloud Service. Let's see, I don't want to save that. So that's a high level overview of the Developer Cloud Service and the pipeline, how that works. Really great tool, check it out. Like I said, if you have a cloud account, you have access to this, go in and play with it. It's got a lot of really great tools. And if you're not doing builds, by the way, the rest of these tools, you'll only really get charged if you're storing files. So you'll get charged for the compute instance, and I believe you get charged for the storage, which both of those costs for this tool are fairly low. All right, so that's like I said, a high-level overview of Developer Cloud Service. And so, true, with all of this stuff, database development is still different than most other types of development, but there are tools out there to allow you to do version control of your schemas and unit test your PL SQL and many other things. And the good news is a lot of this stuff is open source. So you can use things like Liquibase for your version controlling, you can use ETPL SQL, and then you can use something like DevCS to automate the process, which will leave you time to focus on writing your awesome code. Alright, so if there are any questions, let me know. And there are my different channels to contact me on. And I try and be very responsive to questions that I receive on any of these channels or other channels if you find me in other places. But anyway, that's how you get a hold of me, and I thank you for spending your time with me.